Okay, we're going to do some more work on basically problem type questions. We did some work on direct variation earlier in the topic, very similar. The only difference is the work that we did earlier in the topic, it always passed through the origin. The work we're going to be doing here will have a different starting, or may have a different starting value. It may be 0. But always think, look for the question. There's one part of the question which will give you the gradient, and that's going to be some rate. It'll be expressed in like dollars per kilogram or something. It'll have two separate quantities there, and that's going to give you the gradient. The initial value, there'll be something in the question that'll say either when something first starts off or when there's 0 of something, then that's the initial amount. So we'll call it the initial amount. It can vary a little bit. Importantly, it's a fixed amount, okay? It doesn't change as whatever else is in the question does change. That'll make a bit more sense as we get into the examples. Okay, the deal offered by NetShare, an internet provider, to its new customers is a fixed charge of $20 per month plus $5 per hour of use. So importantly, we've got a fixed charge, so this number here will give us the y-intercept. And we've got a rate, we've got dollars per hour, so this is the rate, so M is given there. So M is equal to 5 and B is equal to 20, and we'll come across that in the question there. Okay, so in part A, write a rule for the total monthly cost C of using NetShare for T hours per month. Now basically the C replaces the Y and the T replaces the X. So instead of having Y is equal to MX plus B, instead of the Y we're going to have a C. Now we're told that the gradient was 5, or we worked out that the gradient was 5. Instead of an X we're going to put the letter T, and we had that fixed charge of $20. So in other words, the cost of using this particular internet provider is 5 times however many hours you use it plus another 20. That's a very old way in which internet used to be sorted out, obviously not too realistic there now. Okay, so we now need to graph that. So we need to graph C is equal to 5t plus 20. So the 20 will give us the y-intercept. Now look, we can either go across 1, but and then up sort of 5, because that's the gradient of 5. But in this case, because the numbers are going to be so far apart, let's substitute in, say, 10. So if we replace t with 10, 5 tens are 50, 50 plus 20 will give us 70. So we come up and 70, put our line there, and you can see that we're passing through all of those junctions there. We don't include negative numbers because you can't have a negative number of hours of use. Okay, part C, what is the total cost in a month when NetShare is used for 4 hours? So we've got two choices here. We can either find 4 on the graph, come up till we hit the line and read it across, so it'll be $40. The alternative method is to substitute into this formula here. So go 5 times 4 plus 20, that will also give you that $40. Part D, if the monthly cost was $50, for how many hours was NetShare used during the month? So again, 50 hours, just come across, read off the graph there, that's going to give us 6 hours. So you can see, so long as you've got a good graph, the graph is a lot easier than using the algebra to work out those answers. Okay, a person gets paid $50 plus $20 per hour, so presumably this is like a plumber turning up or something like that. So you notice one is a fixed fee, it doesn't change, so that's going to give us a B is equal to 50. And the other thing is a rate, it's the number of dollars per hour, so the rate is going to give us the gradient. So M is 20, B is equal to 50. So basically we're looking something of the form Y is equal to 20x plus 50. But in this case, P is going to be what we're trying to find. N is the number of hours. And if we take a careful look, it's B. Okay, we've got $1,000 in the bank at the moment, and we're increasing it by $1,000 per month. Okay, we need to find the amount of money after 2 months. So that would be the initial $1,000, plus we'd get 2 lots of the $100. So that's going to be $1,200. After 5 months, same thing, but we're going to be replacing the 2 with a 5, so we'll get $1,500. Part 3, again, after 12 months we'll add 12 lots of the 100. That should be $2,200. Okay, write a rule for the amount of money A dollars after n months. So the amount of money, if we have a careful look, it's equal to 1,000 plus however many months it is times that $100. And look, that's a completely fine answer, but let's write it out in the gradient intercept form. So that's 100n, and that's 1,000. So we've got a gradient of 100, which matches the rate, the dollars per month. That gives us the gradient. And we've got an initial amount, so B is equal to 1,000 there. And that matches our equation there. Okay, we're told that D is equal to 5t minus 4. We need to find D if t is equal to 10. So D will be equal to 5 lots of 10 take away 4. 50 take away 4 is 46. Part B, if t is equal to 1.5, we need to go 5 lots of 1.5 take away 4. 7.5 take away 4 is 3.5. This time we've got to find t if d is equal to 6. So we start by saying 6 is equal to 5t minus 4, and we solve that equation. So we'll add the 4 to the other side, divide both sides by 5, we'll get t is equal to 2. Okay, similarly if d is equal to 11, we solve this equation here, add the 4 to the other side, divide by 5 to get our answer. A sales representative earns $400 a week plus $20 for each sale she makes. So again, we've got a fixed amount, so that's going to be our value for B. We've got a rate, which is the number of dollars per sale, so that's going to be M. Part A, write a rule that gives the total weekly wage if the sales representative makes X sales. So we want to take the gradient and multiply it by the number of sales, and then we want to add the fixed amount. So her wage for the week will be 20 times however many sales she makes, plus the $400. Okay, part B, draw a graph. Okay, I didn't get this one ready. Let's see how quickly I can find a bit of graph paper. It's going to cover up half of our question, but that's life. Here we go, here it comes. It was worth the wait. Okay, so we're going to graph that. I'll sort of use this section and hopefully it'll stay out of the way for the rest of the question. I guess we'll find out. Okay, so we want to graph W is equal to 20x plus 400. So let's just do this. As you can see, I'm not organised. So that'll be X, the number of sales. That'll be W, the wage. Now we want to graph from 0 to 40. Okay, so let's do 10, 20, 30 and 40. If there are no sales, the graph's going to start at 400. Now before I put a marker there, let's see what happens if x is equal to 40. So 20 times 40 would be 800. 800 plus 400 is 1200. So let's go up by 200s. Okay, so that'll get us up as far as we need to be. The initial amount was that $400, and again we just graph that in. Again, a ruler would be better there. Okay, so let's leave that there and see if we can answer the rest of the questions. Okay, rightio. So if she makes 12 sales, we've got a choice. We could come to our graph, find 12, read up in there, but it's not going to be very accurate. Okay, a more accurate way for this number here would be to go 20 times the number of sales plus 400. That's going to give us $240 plus 400 will be $640. Sorry, that should be part C. Okay, part D. Okay, if she earns $1,000, how many sales did she make? Again, that might be suitable for the graph. Let's line it up again. So $1,000, we come across and read off. Okay, so she's made 30 sales. So you notice that one there, it was more appropriate to use the graph because we were right on some of these junctions, whereas say with 12, you know, where's 12? It's sort of somewhere there roughly. We come up and read off, but you know, what's that answer there? It's hard to get it accurately, whereas using the algebra we got that answer exact. Okay, a plumber charges a $40 fee up front and $50 for each hour he works. So again, we've got a fixed fee, which will give us the value for B. We've got a rate, which is dollars per hour. So that's going to give us our gradient there. Okay, so we need to find a linear equation for the total charge, C, for n hours of work. So it's going to be the gradient. Now technically the n is called the independent variable. Then we need to add that initial amount. Part B, what will a 4-hour job cost? We just replace n with 4. That gives us 200 plus 40, so $240. If the plumber works on a job for 2 days and averages 6 hours per day, what will be the total cost? So 2 times 6 is 12. Uh, 50 times 12 will be 600, so $640 there. You notice we don't need to draw a graph. There we were able to answer all of the questions purely algebraically.